This is the 14th lecture of the Mathematics for Business lecture series. Today this lecture topic is differentiation, but this topic already we started and we have covered some extent. Today I will continue the same topic in this lecture. And first, marginal functions. Right? Marginal functions. We know one of the applications of derivatives in a real world situation is in the area of marginal analysis. Marginal analysis. So we know marginal analysis use the derivative. That means derivative or rate of change to determine the rate at which a particular quantity is increasing or decreasing. Therefore, in this section, the marginal functions that we will cover are those for the cost, average cost, revenue, and profit functions. And further, so far we have emphasized the derivative as the slope of the line tangent to a graph. That interpretation is very useful when examining the graph of a function. And same thing also we will continue to use it. Right? So derivatives are used in the wide variety of field in application, and most of the time we use in this field we use this interpretation also. And so therefore the today's sessions main learning outcome is to get the knowledge how knowledge apply basis differentiation rule to business field problem and to get the knowledge how to solve that type of question by using this derivative rules, right? So in business context or economics, when considering the area of economics, the word marginal usually means the derivative or rate of change of some quantity. So thus we are interested in a marginal function such as a marginal cost, marginal revenue or marginal profit. Then we can derive the those functions through the original functions. Right? Marginal functions we can derive through the original functions. That means when derivative the original function. That means thus when we are interested in a marginal function of profit function, this will be the derivative of the profit function, and the marginal cost function will be the derivative of the cost function, and also the revenue marginal revenue function will be the derivative of the revenue function. Right? So this is the one of the strength of calculus in that is provide the good base for some applications, right? Base for some applications in the business world. And so then first the marginal cost function, already you know the meaning of that now. The marginal cost can be defined as the, we can define it as the when we increase, right? Or we can define it change the actual cost of the producing an additional unit. And similar to the that marginal revenue can be defined as the additional revenue added by an additional unit of output. So we can say, in other words, marginal revenue is the extra revenue that an additional units of product will bring a company. So it can also be described as the change in total revenue divided by the change in number of units sold. Okay, so similar explanation we can use for the all kind of marginal functions. So as an example, marginal profit. So marginal profit is the increase in profit resulting from the production of one additional unit. So marginal profit is calculated by taking the difference between marginal revenue and marginal cost. So marginal profit analysis is helpful because it can help determine whether to increase or decrease the level of output. And in addition to that, the marginal average cost also, right? So marginal average cost measure the rate of change of the average cost function with respect to the number of units produced. So then we know the marginal average cost function must be computed by first finding the average cost function and then finding its derivative. So now look at some examples and applications in marginal functions. Okay. And also now we know the derivative mean, right? Differentiation mean to get the dy by dx, right? Dy by dx. When getting dy by dx is 4, we write it dfx. If the function name is fx, so we can write dfx by dx. Right? So this derivation is then the marginal function, right? Marginal function. Any marginal function we can get the get this way, right? And another thing is these marginal functions we can name, right? So we can use some notations to represent these marginal functions. So then therefore the marginal cost, right? We use the MC or C bar to present margin, C dash, C dash to present the marginal cost. So because you can see in it here, right? Because we know after derivation of any function, we to show that, right? That means to confirm already derivated, we use dy by dx, or we use functions name with the dash, right? That means derivative function. No? So this one we can also use for the marginal cost function. Then therefore we can use C dash or MC marginal cost function, and also the marginal average cost function we can use as notation C bar dash, right? If our function's unknown variable is in the x, then we can use x. If it is in the quantity like, then we can use q, right? That means if we have to use the unknown variable name, right? So if it is the average cost, we can use C bar, average cost function. So then these notations we can use, and it's also familiar to us. And for the revenue function also, revenue function, we can use R dash and X, right? To show the, to represent the marginal revenue function. And in here also remember why we use in X, because our function's unknown variable should be represent the via the X, right? And also we can write MR for the marginal revenue. And profit, if we use P for profit, then marginal profit is P dash X. If we use X for profit, then our marginal profit, we can use this. Because sometimes P also we use to represent the demand function, right? So at that time, we have to use another alphabet letter, right? Another letter for the profit, so therefore it can be changed. And yes, this is one example of application of this identified the functions, right? Marginal functions. In this example, you can see monthly demand for t-shirts is given by the function that is demand function, right? You can see demand function P equal minus 0.5 minus 0.05x plus 25, and also it's give some another information that means x should be within within the range of 0 and 400, right? In here, P denotes the wholesale unit price. P mean price in dollars. In here, use the dollars. Anyway, just no worry about that, because here we want to emphasize the money, right? Money, that means the maybe rupees of any type of money. And X denotes the quantity demanded, right? In here, X means quantity, right? So therefore, cost function, right? Cost function is given this way: Cx equal to minus 0.00x 1 x squared plus 2x plus 200. Right? This is the cost function. Then what is the question? Yes, what is the question? The question is here, find the revenue and profit functions. And next we need to find the marginal cost, marginal revenue and marginal profit. And finally it asks find the marginal average cost function, right? So first revenue and profit, right? Then here already given two functions that are demand function and the revenue and the cost function. So when finding out the revenue function, we can do it by using, if we have demand function, right? So when we multiply the demand function once again the quantity, then we can get the total revenue, right? Because we know in here P, that means that equation represents the price, right? So we know revenue means price multiplied by the number of units. Therefore, we can get the revenue function when multiplying the our demand function by x. Now you can see it, right? So this is our demand function. You can see when I multiplying that one by again x, then first term become minus 0.05, x become x squared. Okay. Then 25 when I multiplying that, then it become plus 25x. So then this is our revenue function. We can write revenue function. And now we can find out the profit function, because we know the revenue function and also we have the cost function. So deducting the cost function from the revenue function, that is equal to the profit function. So then here I can write the revenue function like 0.05x squared plus 25x, or minus 0.05 x squared plus 25. That is, we derived revenue function from the demand function, and then we need to minus cost function. Cost function is also already given, but remember, when we minus in this one, you need to be careful this minus, because we need to minus deduct whole whole cost function, right? So that means this minus is relevant or common for all the terms in cost function, right? So therefore, it is better to you put in here bracket. You need to put in here bracket and to be careful that minus sign. So then when I multiply this minus sign in the terms in the cost function, then first cost function become again minus minus plus. You can see, no? And here also squared term is a minus. Then when we simplify these two, you need to deduct this one. You need to deduct 0.1 from the 0.5. Okay, this one minus, this one plus. Okay, so then the answer should be this one. That means the answer should be minus 0.049 x squared. And next, x terms. When I consider in the x terms, here there is the 20. There are 25x and also the minus 2x. Then because when I'm multiplying this 2x which is inside the bracket, it becomes plus. Sorry, minus and plus minus. Then already we have in the revenue function 25 plus x. So then the finally this 20x here. And constant term become again the plus multiple by the minus, then minus 26, right? So minus 200. So then this is the profit function. So yes, this is the profit function. And then it is very, very easy to find out the marginal cost. We need to consider our marginal cost function first, and then we need to derivate it, right? We need to differentiate once. When we differentiate in its one, what is the function now? Yes, minus 0.01 x squared plus 2x plus 200. And this is our cost function, given cost function. Then the C bar become now O C bar x. That means the marginal cost become, we need to differentiate. When we differentiate in here, remember, you need to apply required basic rule. Here, like xn, no? Xn, then we know what is the formula is n x n minus 1, right? So then, therefore, we need to multiply by this n, or we need to put in here the in front of here the term 2x deducting 1, this become 1. Then already there is a constant value minus 0.01, then we need to multiply both together, right? So then its final number we can say it's become minus 0.002 when I multiplying by 2 x. Then when we differentiate in 2x, right? When I differentiate in 2x, it only 2. Okay. So then this is the answer. You can see already I have given it in my slide. Okay. So this is very simple thing. Then that's all in that section. No? Yeah, this is the that's another one. No, the same section. So marginal revenue function and marginal profit function. Series is okay. So we know what is our revenue function. I'll show you in here. Our revenue function is this one. I'll write it in my slide. Revenue function is point minus 0.5 x squared plus 25. This is my revenue function, and my profit function minus 49x squared plus 23x minus 200. Okay, then I can move to the next slide. So you can see now this is the given revenue, already obtained revenue function. This is the marginal revenue function, mean we need to differentiate this one, right? Then minus sign same, multiplying by 0.05 by 2, it become 0.1. And here's something missing, no? It should be x, no? Yeah, 25x, no? So then 25x differentiating, it becomes 25. And marginal profit function also, first term is this one, right? And second term is 23, x is x, and final term is minus 200. Okay, delete this one, right? So now you can see the first term is this one. So when multiplying by it to minus 0.098x, because x is squared, we need to deduct 1x from the power, right? So and then 23x differentiating, it becomes 23 only. So 200 when I differentiating, it becomes 0, no need to put in here. So this is then marginal profit function. So then already, yes, we got the marginal cost function, but now it's asking the marginal average cost function. So therefore, first we need to get the average cost function, and then we have to differentiate that one, right? Average cost function. So what is our cost function? This one. Our cost function, this one. 0.00x squared plus 2x plus 200. Now look at, okay, if this is the cost function, right? If this is cost function, then finding out the average cost function, that means C bar. So we have to divide all the terms in the function by x, because we need average value. Okay, so then I divide in the first term by the x, then I x squared divide by x. What has happened? You can use in here your already learned theories, right? Index theory. So then that becomes this one, this. Okay, so then finally minus 0.001x. Okay, and when dividing by this one also x, that means 2x dividing by x, it become only 2. And when you divide in by 200 also x, so we can't simplify further, so we need to write it this way. Okay, then this is the C bar function. Then if when finding out the C bar marginal, right? Our marginal function of average cost, marginal function of average cost. Now we need to differentiate this function. Be careful when differentiating this one here, right? So therefore, I can write first, before differentiating this one, I can convert this one is little bit easier. The way to easier to differentiate, right? So I can write it this way: 11x plus 2 plus 200x negative minus power, right? When I can get it in the upper side, when then it becomes the minus power. Now we can differentiate that one. When I differentiate in that one, here only 0, 0, 1, because x cancel when we differentiate it. And then here plus, and what I want to do in here, 200, I want to multiply by this minus 1, and x again, according to the rule, right, nx, n minus 1, again I need to minus 1, minus 1. That means only all together minus 2. Okay, all together minus 2. So then, okay. So that means we can further simplify that one, 0, 0, 1. Here now minus, no? Minus 200 x minus 2. Also, you can convert this as the positive index. Then you can write it as the this way, right? 200 divided by x minus 2 here. Okay. And okay, so this is the answer for that one. And next, right? This is another important part, that is higher derivatives. Okay. So that means when we apply our derivatives in some application problems or cases, so we have to get the we require the second derivatives, right? Second derivatives, sometimes more than that. The second derivative of a function of function f is the derivative of x at a point x in the domain in the first derivation. Right? So these are the notation. I will explain how to do that. Right? So when we differentiate or derivate the first time, we write it dy by dx or f dash. If we name our function in f dash. So then second derivative become මේකත් අපි ආයෙසරයක් differentiate කරලා d2 by dx2 or f double dash. Okay. When it's the third time, then we can use this notation. It is the fourth time derivation, we can use this one. Or fifth, nth time, this is the notation. Okay. It is only about the notation. And yes, then this is the one example about the higher derivations, right? So if our function is this one, you can see if the function is this one, when I differentiate in it first, I can use this notation. And after derivation, what has happened in here, what are the changes? 5 multiplied by 3, then it becomes 15. X to power 5 minus 1, that means x to power 4. And second term minus 2 multiplied by 3, it becomes 6. And 1 power, no? 1 minus power 3, that means 2. And when we did differentiate in 14, it becomes 0, no need to write. Then therefore you can see this is the answer for first derivation of the given function. Then if I want to take the second derivation, first I need to put f double dash, right? And then I want to derivate or differentiate all the terms in the already differentiated function. Then that means 15x to power 4, that means I need to multiply by 15 into 4. It becomes 16, and then 1 minus from the x power. That means it's become x to power 3. And then second term, I can put here the minus, right? And then 6 multiplied by 2, it is the 12, and x squared minus 1, that means the power, from the power we need minus 1, then it become only x. Okay? So this is the second derivative. And further we need to third derivative of the same function, then we need to write here with the triple dash with f, because we need to show the third derivation of the function, given function. So then we derivative that one, 3 multiplied by 60, it is become 180, and 1 minus the power of that x value, so this become x squared. And when I derivative the 12x, it become only 12. You can see. Okay. So then this is the third derivative. Likewise, you can get the more higher derivative of the given function. This is also the one more example. I think you can go through that because already I have given question and answer both in here. Yes, the thing is in here, you need to be careful when you differentiating, right? I'm not going to do that, but I just reminding you. When you differentiate in this one, right? This is the portion, right? Right? Division. So therefore, you need to apply the required correct rule, right? Portion rule. So when you apply in the portion rule, you know you need to take the square root of this term, and then you need to do the two parts also. You need to differentiate it differently, right? So you can go through, and I think it is you can understand, right? And then we move to the another important section, that is maximum and minimum point of a curve. You now already you know gradient, right? Gradient means the slope, right? Gradient means the slope of the function. And also you know this slope, right? We can get in any curves, right? Any curve, any point slope we can get when differentiating the function, right? Differentiating the function, and when we substitute in that function's required point on the differentiated function, then we can get the slope of that point. Okay. So however, when you go look at this function that is given in a red color, and my function equation of function is this one: y equal cubic x minus x 3x squared minus 9x. Okay. So after I drawn that one, right, you can see this is the shape of that function, and this function there are maximum and minimum point, right? But when after we drawing, we can understand which point is the maximum, which point is the minimum. But without drawing the function, right, you have to know, understand what is the maximum point and what is the minimum point of this function. So then, another thing is you can see in here, when we considering this maximum point, right, when in this maximum point, slope equal to 0, and also minimum point, slope equal to 0, no slope. But any point in the curve, we can see the slope, right? Different slope in the different point. And therefore, if in the maximum and minimum point, slope 0 mean dy by dx equal to 0. Am I correct now? So when dy by dx equal to 0 of the point in the point of given function, right? Given function. So then we can understand that without drawing this function on the graph, what is the maximum and minimum point of this given function, right? So I know next one, right? Okay. So now this is the given function, you can see, and to get the maximum or minimum point, right, that is the slope, we can first derivate it, dy by dx. When we get differentiating that one, x cubic become 3x squared, you know we need to apply the rule, basic rule, and minus 3x squared becomes 6x, and minus 9x become 9, right? That means this is the slope function, right? Or gradient function of the given function. This is the gradient function or slope function of the given function, right? So that means when we applying any x value in this dy by dx, right, in this one, we can get the slope of particular point of that curve, that function. Okay. So, but in addition to that, we know maximum point and minimum point, dy by dx equal to 0. Therefore, to find out the maximum or minimum point, we can equalize this one to the 0. Right? So then when we equalize this 0 and then we can simply solve, right? We can solve this one and we can get the value for the x. So remember in here, right, now you need to apply your basic mathematics knowledge to solve this, to get the x value. That means solve this equation. So in this case, you can see there are common factor in here 3. When I take in out 3 and the remaining part is this one, x squared minus 2x minus 3. And then I can find out the factors for that part. Right? Likewise, we can get the value for x. Because from x minus 3 equal to 0, then x becomes 3, x equal to 3, or x plus 1 equal to 0, that means x minus 1. Okay? So there are two values of x, but in here, these two values, right? We don't know which one is the maximum, which x is the minimum, but we know now x, when x equal to 3 or when x equal to minus, these 2 points have no slope, that means maximum or minimum value, right? And further, through this, then when applying, right, or substituting this value in the function, original function, you can get the y value also. That means coordinate points, right? I will show you that also for you. Then what is our function? X cubic. You can see x cubic minus 3x squared and 9x. Okay. So then when I apply 3 in here, then it's become 27 first. Right? 3 multiple by 3. Okay. Then minus 3 into, yes, 3 squared 3 means 9, 9 into minus 3, again minus 27, no? That's minus 27, right? Minus 27. And next, 9 multiplied by 3, again it's minus, then minus, another minus 27. So then minus 2 minus 27 and 1 plus 27, then remainder is, that means simplifying, we can get the minus 27. So therefore, when x equal to 3, you can see in here, y equal to minus 27, right? And also when we apply the 1 in the given function, the function is, you know, x cubic minus 3x squared minus 9x. When we apply instead of x minus 1, then you can see in here, no? Minus 1 first, because minus 1 multiple minus 1, again multiple minus 1, then minus 1. Next, 3 minus 3 multiple by minus, so we need to get the minus 1 squared, then it becomes plus 1, and then multiplying it by minus 3, then minus 3. And finally, 9 minus 9x, that means minus 9 multiplied by minus 1. So it becomes plus 9. So finally answer equal to 5. No? So then the second coordinate point is, that means when x equal to minus 1, y equal to 5. Okay. So then the thing is we got the given particular functions maximum or minimum coordinate points, right? Without go through the diagram or the graph, right? And but next, what we want to know, we have to know to identify which one is maximum point, which one is minimum point. For that, Shall we go to next slide, right? Yeah, this is one example. I'll come back in here to example here, right? So, delete everything, right? Now you can see. Yes, now you can see. This is the again the picture, that means the graph, that the same functions graph, and you can see the first function, first graph I have given for you the function, drawing the function, and second graph is showing the gradient function, right? Gradient function of the given function, right? So then one thing you can understand, because this is the gradient function of the given function, that's why I have written here dy by dx in my y-axis, right? Y-axis means dy by dx, that means the gradient. So when the point, maximum point, you can see this gradient point is this way. In the minimum point, right, you can see the gradient point is in here, okay? So then I draw the tangent line for the minimum point also it's become, right? So now one thing you can understand, what already we have done this part, right? So when we draw the line this way from here to here, it shows the negative gradient, right? And when we draw the line this way, it shows the positive gradient, right? මම ඔයගලන්ට කලින් කියලා දීලා තියෙනවා, right? Because we know when drawing the right angle triangle, right? So it's one when we move into the same gradient function, right? So it's horizontal and vertical distance we have to get to identify the slope. So then once horizontal value is increasing, other one is decreasing, right? Likewise, so we know this is the one is the minus, one is the negative, minus, one is the positive, right? So anyway, same, I'm not going to explain same thing, right? We did this in our previous session. So now, therefore, right? So then this gradient functions, again we derivate or differentiate, right? We can get the slope of that function, right? That second derivative. So then the point is, or rule is, second derivation of the function is positive when we apply, when second derivations, after getting the second derivation, and we apply x value, right, in there. So if it is the positive, then we know it becomes the original point become the minimum. If the second derivations equal is minus value, then we know it is the maximum value, right? So I will show you for you. Yes. This one, okay? So you can see if it is minimum, it's minus, right? That means we need to get the d2 by dx2, right? Second derivative, right? The notation for the second, for the gradient of the gradient now, right? Gradient of the gradient. That means gradient of the gradient means second derivation of the given function. Because first derivation or first differentiation give us the gradient, then second derivation or second differentiation give us the gradient functions gradient again. Okay, this like this. So need another color because okay, yes. Now I'll explain you further. You can see this is our original function, right? This one also the same function we already graphed this one, x cubic plus 3x squared minus 9x plus 10, right? So, and after we derivative this function, we differentiate this function, we got the x2x value, and I think this is, what is this? Like, becomes 27, no? Something, yes, mistake, no? Printing mistakes. Typing mistake. So, now our first derivated function is what? I'll write in here, dy by dx, which one? 3x2 plus 6x, yes, then only 9, okay, only 9. The first derivation is this one, the given function. And then second derivation, that means d2y by dx2 is, oh my God, this one is, yes, 3 into 2, 6, and x. 6x plus 1, 6x plus 6, right? Here 6. So this is the second derivation of the given function. Now we want to check whether our already obtained x values are, when we obtain x values in this function, the function, that means function mean gradient functions, gradient, that means d2y by dx2, whether d2y by dx2 plus or minus, just I consider first x value, that is minus 3, all right, minus 3. Then what I want to do, I need to just apply this minus 3 in second derivative function. When applying x equal to minus 3, 6 multiplied by minus 3 plus 6. Then altogether minus 18 plus 6 become minus 12. That means what? That means d2y by dx2 become minus value. That means less than 0, right? Therefore, we know that point is maximum. That point is maximum because d2y by dx2 become minus value when we apply the x value in the second derivated function. Okay. So then next one also we can check if it x equal to 1, because this x already we got, no? Isella got the x value එක මේ function එකේ maximum or minimum කියන්න, right? So then when we apply it to the second derivative function, 6 multiplied by minus 1, no? Yes, 6 multiplied by minus or plus 1, no? Sorry. 6 multiplied by plus 1 is 6, and another 6 here, altogether 12. That means plus, right? Total value or final value plus, that means greater than 0, right? If differentiated one, that means the second derivative function, when applying the x value in the second derivative function, if it is plus, that means our original value is the minimum value. Original value is the minimum value. So, you can see, yes, it is okay. Now I become the my protection, right? Now you can see that one, okay? This is the same, is it same section? No, that's another one, no? So no worry about that. Earlier one is okay, right? So because this one is, no, that means x, when x equal to 1, you can see here, no? When x equal to 1, it is, here, it is minimum 1. When x equal to here 3, no? Other one, 3 or what's our value? We got minus value, no? Minus 3, no? Yes, minus 3. It's, when x equal to minus 3, it is maximum value, right? We prove that through the graphically, and then we know how to do that without graphing, just applying the derivatives, right? When we get in higher derivation, we can confirm that one. So then I move to the another one. Yes, this is one example. I think you can do that by yourself, no? So because I have to discuss with you another important section. So you can go through this by yourself, right? Yes. So then this is another most important section I would like to discuss with you, right? So that means the application part. Yes, this is one simple example. That example says find the maximum and minimum value of the function. Okay, the function is this one. So yes, because I want to manage my time, right? That means to get the best advantage for you. Just I put here the answer for the given question, and then I will explain very quickly, right? So because some calculations, otherwise I have to do the same time. So then time wasting. So just you can, I think you can understand through them. Okay. So then first line, you can see I have given the function. Okay, the function is, you can see x to x, sorry, yes, 3x to power 4 minus 10x to x to cubic plus 6x squared and plus 4, right? So then to find out the maximum or minimum point, we need to get the dy by dx, first differentiation. So when after I differentiate in this one, you can see the value here. 4 multiplied by 3, it's become 12 x to cubic 3 because 1 minus x 4, and second term 10 multiplied by 3 minus 30 x squared plus 6 multiplied by 2 12x. Okay, so then what we want to do, because maximum or minimum point, our functions slope is equal to 0, right? So therefore we can equalize this into the 0. When we equalize in it 0, then I want to find out the value for x. For that, we can use factorization method. And first I removing the common factor, that is 6x. And then finally it's remaining 2x squared minus 5x plus 2 equal to 0. And then the three terms, quadratic function inside the bracket. And I can get the factors for the quadratic function as 2x minus 1 and x minus 2, right? You already known things in here applied. And then we have three answers for the x. 6x equal to 0, 2x minus 1 equal to 0, and x minus 2 equal to 0. Through those equations, we can get x equal to 0 because 6x equal to 0 means x equal to 0. And 2x minus 1 equal to 0 means x equal to half. And x minus 2 equal to 0 means x equal to 2. So then we got the three values for the x. That means when x equal to 0, half, and x, that given functions, those given functions as a maximum or minimum value in that point. And next, to identify whether which x values are maximum or minimum, so we have to get the second derivation, that is d2y by dx2. Okay, so when we get in the second derivation, we can get the answer, that multiplying 12 into 3, you can see here, I will show you in here, okay? When multiplying, yes, first derivation, this one, multiplying 12 into 3, you can get this 36. And its x cubic become now x squared, okay? And then next term, because now I am derivating, right? That's again differentiating it. 30 multiplied by 2, it's become minus 60. And x2 minus 1, it's become x. Then 12x differentiating, it become 12. You can see, okay? So then second derivative, right? Function is this one, right? So now we have to apply one by one. Already we obtain value for x. The values are these three, okay? When I applying here 0 in the second derivative function, first term becomes 0, second term becomes 0, finally only 12. 12 means it's a greater than 0. Therefore, we can recognize this when x equal to 0 in this function should be a minimum value, right? Minimum value, because it's greater than value. It's okay, right? Then I can check the second value, that is x equal to half, right? When I apply it into the derivative function, 36 half squared minus 60 half, 60 multiplied half plus 12. So the answer is equal to minus 9, okay? Minus 9 means it is less than 0, right? Less than 0, that means negative. If it is negative, we know according to our rule, that point should be maximum. That point should be maximum, right? And further you can apply another one, no? Where is our x equal to 2? No, we got another one, no? X equal to 2. Yes, you can do that one here, no? When x equal to 2, dy by dx equal to 36. You can check it, no? When x equal to 2, you can apply second derivative function, right? So then here, when we apply 2 here, so time is wasting, you can do that simplifications, right? So then otherwise time is wasting, so I'll just go to. So then finally, however, it's the answer is 36 mean greater than 0. That means again positive value. That means this x equal to 2 value is the minimum value of that function, because the second derivation value is greater than 0. Okay. Therefore, we got the three among these three values, right? Find half and half and 2. No, the half and 2 got the minimum value, and when x equal to 0, function is has a maximum value, right? Then function has a maximum value. So same time, right? If you want, because all these three are x values, no? X half, x2, and x0, right? So if with x equal to half, our function has a minimum value. If x equal to half 2, no? If x equal to 2, then also our function has minimum value, but our when x equal to 0, our function has a maximum value, right? So if you want to do identify the point, that means y also, right? Y also for the given 3x values, just you have to substitute these values separately. Be careful about this. Need to apply in the original function, not the derivative function. Okay. When you apply this x value in the original function, then you can get the y values. All right. So this is the very I think, clear example for you, right? So just only one I will explain you. And the example is here given the revenue function, that is the x r equal to 800x minus x square. So what they ask in, determine the demand function and find the marginal revenue when x equal to 150. Right? The first we want to identify the demand function. No? What it asks in? Oh yes, demand function. But you know, right? If we have the demand function, we can get the revenue function when multiplying that one number of units. So I will show you. If we have P, then we multiply it Q, quantity OX, we can get the R. If we have R, then we can get the P. How? When dividing it's by nether. We can get when R equal to P multiple Q mean, then P equal to R divided by Q. Q mean here number of units. But in this case, number of units given with the not the Q, X. X only, right? So to get the demand function, we want to divide revenue function by the x, right? So then we divide in x, x become 800 minus x, right? And so this is the demand function. And then total revenue function already given, R equal, R equal 800x minus or plus. Yeah, I use minus, earlier one I use, I don't know. Anyway, right? So in here I consider it as a minus x square. So therefore then marginal revenue, it's very easy how we can get 800 minus 2x. Right? This is the marginal function there. So then it starts in the question is find the marginal revenue when x equal to 150, right? So it is very easy. Oh, yeah. Okay. Did this part so my slide? Yes, no? Yeah. This one, no? Okay. So we have to apply, or we need to substitute x equal 150 in the marginal revenue function, right? In the marginal revenue function. So when applying when x equal to 150 in the marginal function, then we get the answer, right? So I think it's okay. And so then I have given one more example in here, right? You can see already I have given the answer for that one. So then because now our time is over, right? So now I have to wind up this session, but I want to remind you one thing, right? So I will upload these slides in your LMS page. So please go through and you just learn this one by yourself, because in here I have given question and also the answer. Then you can understand and you can get the good knowledge regarding this lesson, right? Okay, then I will wind up the session. Thank you.